For the question formulation system, we have decided to proceed as follows. We first split the text into sentences by detecting sentence boundaries. We then score each sentence based on how well it is suited as a question, and perform pronoun resolution on the sentence as necessary, and then invert the sentence based on a set of rules. We first preprocess the article's HTML file, removing all headers and lists as we did not have time to infer from these, and Core NLP gives improper parsers when these are included. We then run the Core NLP toolset on the preprocessed article. We score sentences based on the density of named entities, that is, the number of named entities divided by the total number of tokens in the sentence. To avoid fragments, we limited sentences to have at least 3 tokens, required the pass to contain at least 1 noun phrase and 1 verb phrase, and require that the pass does not contain any colon tags. For each of the sentences, we remove the prepositional phrase before the noun phrase, if any. Furthermore, if we encounter any coordinating conjunctions in the sentence, we split the sentence into 2 or more sentences, with each of the phrases linked by the conjunction. Lastly, if we find any nominative pronouns in the sentence, we replace that with the most common non-pronoun reference in the co-reference set as determined by Core NLP. To invert sentences into yes-no questions, we search the parse tree for a verb phrase subtree. There are 2 kinds of verb phrases, those with a modal verb and those with only the head verb. We distinguish these sentences by searching through each of the subtrees of the verb phrase subtree to find a second verb phrase. If it exists, we need to find the modal verb, which, as we have found by examining parse trees, is often the first child of the first verb phrase we found. We create the question by placing the modal verb before the noun phrase and the rest of the first verb phrase. To deal with the second kind of verb phrase, the one with only the head verb, we check if it is in past tense. If it is, we add the modifying verb did to invert it and use pattern.en to conjugate the head verb into first person present tense, which is generally the infinitive form. This leaves sentences in present simple tense, which are significantly less common, and therefore we add the phrase "is it true that" before them, which turns them into a question while retaining the sentence structure. To generate WH questions, we examine the tokens associated with the different words in the sentence. We utilize the named entity recognition tokens provided by the Core NLP package. We check for a person token or a location token, depending on which sentence we are generating. We then replace the person's name or location's name with the appropriate question word, that is, who or where respectively. Replacing the name in place preserves grammar. Even if Brian went to where sounds a little unusual, it is still perfectly grammatical, and in fact colloquial. For the answering system, we evaluate the text corpus based on the number of keywords shared with the question provided. We then focus on parsing a small set of sentences with the highest number of shared keywords, from which there is a high probability of finding the correct answer. We then pass this on to the appropriate functions, which fall into 3 main categories: yes-no questions, WH questions, and why-how questions. For yes-no questions, we further split these into 4 categories based on their parse tree structure. We then handle each of these cases separately. The noun phrase case uses a dependency parse to check if the nouns are correlated. It parses the main nouns of each noun phrase, then checks if any pairs of nouns across the 2 phrases are dependent on each other. The noun phrase prepositional phrase case finds the smallest subtree that contains a main noun of the noun phrase and the prepositional phrase, as well as a similar preposition in the prepositional phrase. It then analyzes the subtree to find the correlation between the 2 by counting the number of negations in the subtree. The noun phrase adjective phrase case identifies the main noun and the main adjective keywords, and parses the corpus sentences to identify the subtrees containing these keywords. The system determines whether the adjective corresponds to the noun by traversing backwards up the tree to ensure that the verb phrase subtree containing the adjective has a sibling noun phrase subtree containing the noun. The noun phrase verb phrase case identifies the main noun and verb of the question, and then finds the sentences within the corpus that contain those words. The system then answers the questions based on a set of criteria determined by the question sentence and the corpus sentence. For WH questions, we further split the questions based on the question word. Let us look at the way what questions are handled. The system first extracts the main nouns and verbs from the question and goes through the corpus to identify the keyword sentences containing these words. It then determines the part of speech that the answer should be. For what questions, the answer could be a noun or a verb. Let us consider the verb case. The system extracts possible verb answers from the corpus sentence and then uses it to create a yes-no question. If the system finds the verb, it will pass the sentence back to the functions that handle the noun phrase verb phrase yes-no case. If it receives a yes in response, it will return the verb that is substituted. Otherwise, it will continue iterating through the verbs in the keyword corpus sentences. For why-how questions, we include targets such as because or since with the main nouns and verbs in the question, when searching for sentences in the corpus that are most likely to contain the answer. We then return the clause containing a target if it exists, or return the entire sentence if it does not. Staplerisation is an NLP project by Simon Tiao, Jane Chua, Melanie Xia, and Kern Hans for CMU Course 11 for 11. No Brians were harmed in the making of this video.